This will be a short video describing COrnLathe. COrnLathe is short for Computerized Ornamental Lathe. It's a program written by Bill Ooms. To find COrnLathe, you go to github.com. This is a repository for open source software that's free to use. If you search in the top right corner for COrnLathe, you'll get three results. The first one is COrnLathe written by Bill Ooms for the Mac operating system. Unfortunately, I think this does need some recompiling, and I have no way of doing that. I have an older Mac running Catalina operating system, and it works fine on that, but my more modern Macs don't allow it to run. The second page is empty. The third page is one I posted, COrnLathe for Windows. If you left click on that, you'll get this web page. These files are everything you need. This is a file I've extracted from COrnLathe that contains all the help files. This one is COrnLathe for Windows, and this is all you need, really. This last one is an extra copy of the examples that Bill includes in his program. The instructions for how to install it are quite straightforward, and they're here, but we'll go through that procedure anyway. There are two ways to download this series of files. One is to go into the code button here, and you can download the zip, and that'll include all of the files that you see listed there. The second way is to go and left click on COrnLathe for Windows, and you bring up this page. If you go to the three dots here and left click that, you see a download button. If you click that, it'll download. You'll see the progress of the download up here, and you can open a file where that is. So we'll go there. Here's my version of COrnLathe for Windows. I chose to put that in a file labeled COrnLathe in my Documents folder in my Windows C. Now you will also need Java. Java is the underlying structure that allows COrnLathe to work, and you can download this from java.com for Windows Macs or Linux computers. So once you get your zip file in a convenient file location for you, if you right-click it on ordinary Windows, you can extract all the files, and you can put it in this folder. If you click extract, then Windows will look after that, and what you will get is this file here. If you open that up, you get another COrnLathe file. If you open that up, you have the files that you need. If you go into the bin file, you'll see My Lathe, and if you double click on that, the program will run. So here it is started up. It shows up in the toolbar at the bottom, and if you right click, you can pin it to the taskbar, and then you don't have to go looking for it in your folders on the C drive. This is the usual default layout that you see for Windows, and it's one that works very well. I would suggest not trying to move around the different tabs. You can, and you can resize all the windows. That's straightforward stuff, but you may end up with them all located on the left side of the screen or in places where you don't want them. Now, this window here has three functions. It allows you to choose a file you want to play with. It allows you to view that file, and there's another tab for generating the G-code. If one of these tabs is not there, you can go to the window and put it there. If you click on G-code, for example, then that will show up here. This window here is where you can design your work of art. This one down here has some variables that you can also design, including the thickness of the material and where the cut points are going to be, the type of cutter you're going to use, the view or the location for the cutter, the radius of the cutter, tip width, and the type of drill frames that you might be using. And I'll come back to that later. This Data Navigator window is going to be quite useful later, and I'll show you what to do with that. The fifth part of this is the different types of cut points that you can apply to a particular piece of work. To get started, you need to be able to access some of your files. So if you right-click here, you can add to favorites. So in this case, I have COrnLathe installed in my Documents folder, and I pulled out the Examples folder out of the COrnLathe for Windows folder and made it a little more convenient. If I click on that, you can see all the different types of examples. So if I add the Examples folder, here it is showing here. These are copies of the same examples. Now, if you double click on one of these, for example, netting XML, you'll see something interesting happens. This is an example Bill has done, and I must state here that COrnLathe works in inches. When you output the G-code, it is in inches. These units on the screen here don't necessarily matter that much, but if you just think in inches, that makes it all easier, believe it or not. This is X and this is Z. We can look at this thing by going to the 3D viewer. You can use your zoom button on your mouse or your right-click button to drag it around. The zoom button goes in and out. Now it looks like this is illuminated on the inside. And if you look at this little button here, it does show an arrow pointing at the inside. If you click that, it's illuminated on the outside. These lines represent the cut points that have been designed over here. And if you click Render, the program will calculate what those will look like, and you can see what that pattern would look like on your workpiece. You can turn the lines off so you can see a little more clearly. You can turn the grid off. And you can start to make changes if you want. This is where this window comes in handy. There's 10 cut points. They start at 0 at the bottom and go up to 9. If you click on this, you can see features of all the cut points. So the first cut point, 0, you can look at that and go to the Properties window here. Pull that down a little bit so we can see it. And that'll show you the X location as 1.5. So if you put your cursor on here, you can see with this little part here that this is the location of the cut point. I'll come back to what these circles all mean and the different colored lines here shortly. It's most useful, I think, to pick apart some of Bill's examples to understand what he's done. To get to a different example, just go back to favorites. Let's look at basket, for example, or maybe bamboo. Double click that. Look at the view. You can render it. And there's your bamboo pattern showing up. In this case, this piece is 2 inches wide. The cuts start at the bottom and go to the top. There's 11 cut points in this case. The spacing can all be adjusted. Now if I add another favorites window, so I right click, add to favorites, and I can go and add this folder. Now in that test folder I have one called honeycomb, and I've just made this using my Explorer window. I just created a new folder and called it test. So this is the one we're looking at. If I drag and drop another file in there, it'll show up immediately in COrnLathe. So let's do that. Here's the examples. Say I want to look at basket. So I can copy that one, go back up, go to my test examples folder, and paste that there. Why do I show you this? It's nice to keep your examples as they were, these ones. If you start changing them, they're changed, and then you have to figure out how to go back and unchange them, and that's not very convenient. So by having them pulled out of your basic examples folder into one that you can play with, it makes it a lot easier. So here's basket. I'll go to that one. We'll render it. And that's a classic basket weave pattern. Now if I go to Data Navigator, open up all the cut points, and I can't see them, so I'm going to make this window a little bigger. If I collect all of these in one by highlighting the first one, holding shift and clicking the last one, there's multiple objects in there, but I can change some of the values. So if I tell them not to be visible, they disappear. They're still there, but they're hidden. If I click the render back on, you can see what that's going to look like. I right click to move it up there and zoom in and out with my scroll wheel. I can come to this here and maybe put that right in the middle, and as you see, that changes quickly. If you have all 11 cut points, it's going to take a while to recalculate. So this is the orientation of the cutter. Fly cutters, in this case, are used in a vertical orientation, which is in this orientation to the workpiece. Now, I'm going to cut away to a live view for this, and explain this concept. So I thought I would show in the real world how this works. In COrnLathe, you see the piece oriented vertically like that, with the bottom being here. But in the real world, of course, you're looking at them like that. If a cutter's plane of cut is in this plane, that's called the horizontal mode. If the plane of cut is in this way, that of course is the vertical mode. This is a little fly cutter I've made. See if that shows up there. This has a 1/8 inch carbide bit in it. This is sticking out far too much. Normally it would only be out a 1/4 of an inch, which is a few millimeters, and turning clockwise like this. If the cutter is oriented horizontally and moving past the work, you'll get a pattern like that. If the cutter is oriented vertically and moving past the work, you get a pattern like that. These little cutters can take out quite a bit of wood depending on the radius of the cutter tip, and you can get some large flat sections like that with several passes. When you're looking at COrnLathe and you see the cutter oriented like this, that's in horizontal mode. And you'll see that on the side screen with the cut points. If you see it end on like that, then you won't see the circle. The other thing that's illustrated in the cut point window is the axis of the cutter, and the radius goes from there to the tip of the cutter. So to resume where I left off, you can see here the cutter, the fly cutter, edge on. If I go to the cutter over here in the Data Navigator, highlight that, go to Properties, I can show you what happens if you change the orientation of the cutter. So now you're looking at the top of the cutter. And if we render the cut, so you get a different cut. COrnLathe is capable of orienting that cutter at all kinds of different angles, but I'll try to keep this simple. So if I want to design something new, I would come to my test examples, right-click on the folder, here's new, and Bill has some templates in there. And you have to look in Other. Here's a template, COrnLathe, and I can name it Test Shape. So here's my test shape. In my window, I can view it. Looks like it's looking at the bottom. I want to look at the top. Can tip it with the left mouse button like that, and I can move it around with the right mouse button. So this shows a sort of a shallow bowl shape. If I want to clear all cut points, you'd click here. Right now there are no cut points. If I want to clear all the points, I'd clear that. So now I can start making my own. Each of these vertical lines is 1 inch. So I find it convenient to work on 2-inch dowels just to see the pattern. If you go here, it's in outline mode. If I double click here, there's a point. If I double click here, be another point, but I'm going to put it off a little bit to show you something. So that gives me the shape. I want to be outside, and what that did was locate the axis of the cutter from the inside to the outside. And I want to view it over here on the outside. Now these lines are offset. If I want them vertical, I go here and say 2 lines vertical. Now I get a cylinder. If I want another line, I can click here. He's got the math to give a fair curve. You can move that one up. You can move it in. You can put another one there. Move that out. Or if you don't want it, you left click and hold and drag it off the screen. Either way. Now typically you're going to cut with a rosette. The cutter right now is ideal, and that's the fastest rendering. You can put different points on there, but it slows down how fast the program reacts to your changes. You can always do that later. Right now it's what's called a horizontal cutting frame. So it'll cut. We'll see the top of the cutter here. So here's a rosette point I want to put on. And you put it on the axis of the cutter. It's cutting in a horizontal plane. And the default cut is sine 8. You always see that one. So let's see how it looks. Gives you dots. If I want to change that, I highlight that. Here's the 8. I can go to 16. Enter. And that's what I would see. I can go to 32. That's what I would see. I can move this down if I want. It'll relocate in the model. But I'll put it up. And if I double click on here, it'll reproduce the settings of that one. And if I want them located just a little bit closer like that, I can do that. So a common thing in ornamental turning is phasing, pH. So this second cut, I can go and I can phase it right here. This is in, right now, the default is set for degrees around a circle. So if I put it 180 degrees out of phase, enter, it shifts over. If I do another point down here, it'll be the same as the last point. If I move that up a little bit, it'll show up in your data navigator. You go down here and put that back to 0 if you want. Maybe you only want that partly phased. So if you go back to this one that we put at 180, and put that at 90, you get a little bit of offset with each one. You can change settings all at once, multiple objects and properties, so not all of the properties will be available. So when you highlight everything, you can't get them. But say you want to change the depth. That's the depth right there. And what I did was click on one, hold the control key down, click on the next one, keep holding it, click on the next one. So on this one, cut depth is 0.05. can change it for all of the cuts to 0.075. See what that does. Click the render button once, that turns it off. Click it a second time and it brings it back on. So you can see there's a deeper cut there. These are rocking, and the ornamental turners will know what that means. I can change that from rock to pump for all three. So instead of going in and out, it goes up and down. Click it again, get the rendering. So there's a different pattern. Maybe you don't like having 3 lines there, so you get rid of one. Drag that one down. Now if you look here, you can see the cut depth. Looks like it gave me another point that I don't want when I was doing that. Get rid of those. You can see how it rocks back and forth according to that sign. That's as far down as it'll go, that's as far up, and this shows you the intersections of those. If you don't want them to intersect, you can pull it down, or you can pull it back up, and that becomes important when you're overlapping patterns. That's not actually a very pleasing pattern, so we'll come back to this, left click that, hold the shift, left click that, we'll go back to rock. And render that again. Now there are several choices here, some of which I don't understand. This is perpendicular, this is tangential to the surface, this is both, and this is a perp tan setting, and I don't have the means of doing that with my simple metal lathe adaptation, but those are things you can experiment with down the road. You can clear all the cut points and start on something else. Maybe you want to do a spiral line. So I'll drag that. I've left clicked it, dragged it over. This shows that it has 2 points. So I left click it and drag it down. And there's a default spiral line, which doesn't look like much from here. So we can go over to the data navigator, open up the options, that shows uniform depth and how much twist there is. So if I want that twist to be only 45 degrees instead of 90, I'll change that, and that's changed it up. This has defaulted to the sine pattern. This can be any of the other rosettes. There's a whole bunch in there. Plus you have the ability to make your own. Now this is where you can change amplitude as well. Right now the amplitude of the cut is 0.1. Let's make it 0.3. You can see the lines got wider. This isn't much of a pattern, but that's fine, it shows. If you want this vertical, put that to 0 and it goes straight up, and the pattern becomes even worse. So say I want to change my cutter. This is a horizontal cutting frame right now. So say I want to draw in there. It's got some points to calculate. And I'll close that off, but what it'll do is just a line in there. Because it's an ideal cutter, it doesn't show much. So let's put that at a 90 degree. Here's the point 90. So let's try rendering that one. That'll have a little better luck. The ideal cutter is very fine. Wow, that was nice. Cut too deep, obviously. So the depth is here. Still too deep, but that's fine. You get to find out about things like that. You can change the thickness here, and the orientation of this is sort of down. So if we change this to 90, sometimes you got to persuade it. And it hasn't changed this. These should be pointing this way. When you're changing on the fly like this, sometimes it's a little stubborn. There we go. So since we have that working, let's change the number of repeats. Let's change the rosette. Let's go to a lotus rosette, see how that looks. So that gives a little bit different shape. And you see over here the drill frame rendering has changed, so it's cutting in. And I can change the lines again just the same. So what I encourage you to do is to go into these favorites, examples, in an ordinary window, go into the examples and take a couple of them, copy them, paste them into your test file, and then you can rename them whatever you want, just as usual. Test 3, let's call that one. Minimize that, and you'll see that test 3 has showed up here. We can look at it, render it, and maybe you like that, maybe you don't like that, but you can see what Bill has done with his different options down here and change them for yourself. From rocking to pumping, you can change the depth, you can change the amplitude, you can change the phase, you can change the number of repeats, you can invert it. That one's fun. That's like cutting from the back on a Rose engine. Or you can change it altogether, whatever you want to do. Now, once you have your wonderful pattern created, you can go to the G-code window. And you want to go to this. This one will cut the pattern. It'll generate the G-code to cut the pattern. This one will actually cut the outline. If you've got a curve and you've turned a piece that's pretty close to the curve that you've designed, you can refine it with this. And thread cutting, of course. But what I do, since this was designed for Bill's lathe and Bill's Linux settings, is I crank the speeds of those up all the way when I'm cutting rosettes. I may change the depth of cut per pass. You can change the direction, always positive, always negative, or always positive on rough and always negative on final. The risk with this is unscrewing your chuck depending on how you have it mounted. And to write the G code, you just click here. So this one is called test 3. So if I go to the G code window and I write the G code down here, it's saving the file as test 3, and that's a G code following. If I go into where that file is, in my test examples, here's the G code right here. I can look at this with an ordinary text editor. I use Notepad++, which is free. And this shows your starting point right here. So the X direction, which on a metal lathe is coming towards you or going towards the center of the lathe. The Z direction is from left to right. So this one, that's where it's going to start. So you set the point of your cutting tool right there and right there. Adjust your G code sender so that it thinks it's right there, and you run it. The units will always be in inches. I've looked and there's no place to change it to millimeters, I'm sorry to say. The other thing is it runs G93. So if you're running a G code sender that doesn't understand G93, which is a way of combining the movements of these three axes together, and this is the speed that it's going to do it, then you'll get an error that it doesn't want to run G93. But if you're using something like Mach 3 or Gerbil to run your programs, those will work. So that's how easy it is to write the G code for that. That'll show up in your favorites thing right here. You can't run that ordinarily from within COrnLathe. Bill designed this to run with Linux CNC, and not that many people will be using that for this purpose. So I think it's worthwhile for people to go out, look at each of these, and see how it works. Some of them, like butterfly, you need an eccentric cutting frame to be able to do this. Or you can cut it on an ordinary lathe, you can cut it right on the axis. But to get it to cut on the sides like this, you have to be able to tip the work on your lathe and then have that as the center of rotation. Most of these, offset group is another one. Most of these demonstrate the majority of these features right here. But that's for a different presentation. So I hope that's helpful for people to learn how to navigate around COrnLathe, how to find it, how to get it installed on a Windows computer, the importance of some of these different windows and tabs. And what I haven't touched on is things like Pattern Editor or Rosette Builder. Rosette Builder allows you to combine different rosettes together to get your pattern. Pattern Editor will show you the rosette. So this is, the virtual rosette for butterfly, as you see down here. If you want to see any of the holds, they're all in there. If you want to make your own, that's quite possible. If you want to see a normal sine, that's a sine. Half sine. Lotus looks like that. And if you want to make a new pattern, you can start playing with that, but that's a different presentation. To get back to where you were, just click on that. If you don't want to see these windows, you can just close them. So I'll end my presentation here, and I hope that's been helpful for people. And I look forward to making another presentation for you next time. Some online resources I can recommend are going to Bill Ooms' website, Mr. Bill Ooms, and looking particularly at Resurface 2 and Resurface Advanced. Resurface was the predecessor to COrnLathe. The other presentation Bill does is on the Ornamental Turners International site, his presentation in 2016. He talks quite quickly and shows some of the features of COrnLathe.